introduce what this project was about, talk about today's path, talk about tomorrow's practice, and then conclude. So this is our mantra for water stewardship group at Affiliate Engineers. We always want to reduce, reuse, and recycle, but before that and after that, we want to rethink what are we doing. And are we doing sort of the route of what we've done before, or are we really pressing ourselves to rethink? So in this exercise, as I said, one of the, and perhaps in this room, one of those world-renowned healthcare architects asked us this question. And we decided, okay, well, we're game, this is going to be fun. And they said, okay, here's the campus. It's going to, this is the real-life campus in south of San Francisco. It consumes 25.5 million gallons of water every year. It releases 18.25 million gallons of water per year. And that's the count of the gross square feet for the medical office building, the parking, the office, the hospital. And if you're not familiar, WUI is the water equivalent to EUI. It's the water use intensity of the building. It's the amount of gallons per year per square foot, or gallons per square foot per year, rather. And so what you see here is that a hospital, just like Frank just introduced Robin Gunther talking about energy, a hospital has a water use intensity of 50, whereas an office has 24. So that's actually just like what Robin was saying about energy. She was saying the hospitals are twice as intensive in energy use, they're twice as intensive in water use. This is the location, characterized as a medium to high risk water location. This is the starting point. You look at what's the precipitation pattern, and what you see, of course, is you've got some very, very dry months in that climate. And then this is the first video I'm going to try and do. What do you think I pressed?
Just put the mouse over the image.
Just left click? Whoops, no. Sorry. Oops, I know I messed it up. Back up one. Just over here. Just go right there. And press select. Okay. All right, climate change, drought. So you're looking at our federal government's analysis of drought going forward. Pretty upsetting and very certain. So whatever the climate risk is now in that location south of San Francisco in terms of water availability and water quality, it's going to become much more intense. There's going to be much more need for us as hospital designers to think about how do we create a building that uses no water or hardly any water. So let's talk a little bit about today's path. Anyone in this room recognize this building? Show of hands. That's it? Okay. This is called the Bullitt Center. This is a building in Seattle, which it has a lot of wonderful attributes, but I'm just going to focus on the fact that it has broken all sorts of perceptions of how water efficient a building could be, including some maybe 5 or 7 years after it was opened. It got permission from the city of Seattle to actually reuse its wastewater as drinking water. So it's got the capacity within its basement to clean the water and set it back upstairs for people to drink. That's equivalent to the water that we drink from our water treatment plants. The Bullitt Center was meant to be an example for everyone, and it's been talked about and written about, and I certainly encourage you to take a look at the wealth of information about it. But then something wonderful has started to happen, which is scale jumping. So now in the city of San Francisco, all projects over 500,000 square feet have to reuse their water. So a lot of the concepts that happen in that little building are now happening at big projects all around San Francisco. An important thing to remember when we're thinking about stretching our minds about what's possible. So what's different about this than the Bullitt Center? Whole different building type, talked about briefly, hospitals use essentially twice as much energy per square foot and twice as much water per square foot as does an office building. So when we read about the Bullitt Center, we get all charged up and excited about it, and then we go back to what we're really passionate about, designing hospitals. It's a little sobering because the challenge is all that much different and bigger, but still these things to be learned from the Bullitt Center. In our office, we call this the double donut. I think working in Wisconsin, people must drink beer, eat cheeseburgers, and donuts. So what this is this is sort of our working, quick, always reminder of whether the building is here in Kansas, whether it's in Wisconsin, Seattle, San Francisco, New York City. There's a relationship between the energy use in the building and the water use in the building. And so as architects, you want to make sure that when you lead teams, you're asking your engineer, what are those trade-offs and what makes best sense for the situation that you're in. So here in this challenge that we had from this architecture firm, we wanted to make sure, for example, since there was no balance on energy, we would always be looking at if there's a technology trade-off in a given technology or the options, if there's a trade-off between how much water and how much energy it uses. In this situation where climate change is telling us water is the most precious, the more precious resource, we're not only looking to reduce it, but we're looking to reduce it by sacrificing the amount of energy if that's what we have to do. So ideally, you reduce them both. Let's talk about tomorrow's promise. This is our U.S. energy and water flow in 2011, and some amazing things are happening with energy. Contrary to the President's commitment to coal, the amount of coal that we're producing in the United States is actually being reduced. The amount that we're using is being reduced more dramatically than the amount that we're producing, because we're still exporting. But what we do see also is that energy sources that use less water, those are the non-fossil fuel energy sources, are having a lot of growth within the United States. So if we're actually thinking holistically about our buildings, we're thinking not just about the energy and the water that's being used in that building, but we're thinking about how much energy and water is embodied in delivering that to our site. So, next generation technology, what is it? So there's going to be broad incremental improvements in technology related to lighting and insulation. Those are things that you as architects worry about. Phase change material is also an architectural issue. It's going to be more ubiquitous and lower cost controls. That's an engineering issue. The one that you drive as the architect. Improved weather predictive controls, wireless toilets, broader water quality, and some medical equipment. So that's the challenge for your medical equipment planner. And lower cost packaged water treatment systems. The photograph on the right is a brilliant young person who is standing in front of what? Pardon me? He's standing in front of his recycled shower. The water that drips down on his head and on his body goes into a drain, comes back up, and continues to wash it. A little kooky, it's a funny sort of expression that he has on his face, but the message is, my message to you is, don't dismiss these people. So here's an example. These people are on their second round of funding, and they're doing the same thing. They're innovating.
We are Network. Since we started, we wanted to bring the world's best shower to as many people as possible. This is our third Kickstarter campaign. At this point, we know a lot about showers, and we think this is our best product yet. Over the past 5 years.
So what this is it's a shower that uses it delivers twice the moisture experience with less than half the amount of water. So here's somebody who probably looked like that guy in the shower. He's on his third level of Kickstarter funding. He's been guided to or otherwise figured out to partner with a major manufacturer, and he's got a product that's being sold all across the world that's good for energy and good for water. Isn't this letting me do this? I don't want to listen to this again. Yeah. Sorry about that. Click out there. Okay. All right. Now this guy, I'm gonna fast forward to three minutes into him. He's very funny. He's from representing Hydroloop. Hydroloop is a wastewater treatment facility, just like what I talked about in the Willa Center, but it's in your home. Let's see if I can do this once again. I'm going to fast forward 3 minutes in. Don't be offended. But it takes him 4.5 minutes to describe this project. All right.
Dirt that is connected to the skin of the water bubble that goes to the surface, and then it becomes foam, and we skim the foam off. By doing this, we lift the dirt out of the water. This is the Hydroloop app. Everybody at home has an app, and the app shows how much water you recycled yesterday. And it also tells you have enough water for the washing machine. If it's blue, and you don't have enough water for the washing machine, it will tell you in 45 minutes you have enough. So you can just wait a little bit until you have enough recycled water for the washing machine. And by the way, congratulations, you didn't use any mains water to flush the toilet yesterday. And here it shows how much recycled water you still have available. We tested the Hydroloop in the past 2 years in many places in the world, like South Africa, Namibia, Dubai, UK, Belgium, the Netherlands, Denmark, Poland. And now we are really, really ready to roll out. And starting.
All right. So, can you imagine in your home that you would have next to your furnace, you're going to have your water recycling unit. And as he says, you're going to manage it on your app. It's going to tell you you've got enough water that's been cleaned, that's ready to do your dishwasher, or not. And it's just going to be that same water over and over again within your building. This replaces the systems that we have today that go remote. So with this sort of stuff as inspiration, we started looking at, okay, we've got this 25 million gallons per year that we need to worry about. What are our today's best management practices and what are tomorrow? So the first thing we did is we looked at irrigation. And we reduced the, so the way to read this is existing is the standard that the campus has today. And then what best management practices today would have is the shorter purple. And yellow is what we think can happen in the future, just 10 years from now. So the water savings, the easiest thing to do is to think about irrigation. So we reduced that. We analyzed the energy efficiency. Today we're looking at orientation, massing, envelope, plug lighting, all architectural issues. In the future we're looking at additional technologies like super insulating materials and phase change materials. And so we're reducing the energy that's associated with it. Then we look at the plumbing fixtures. We look at the high efficiency plumbing fixtures available today. We contemplate the high efficiency plumbing fixtures of tomorrow. And this is not a fantastic exercise. It was a rigorous exercise based on a lot of practicality and research about these ideas that are coming to the market, these products. This is my favorite one. It's equipment. So it doesn't belong to the architect, doesn't belong to the engineer. It belongs to that wonderful thing, that person, that equipment planner. And today, all of the equipment planners know everything they need to know about the energy efficiency of their medical and scientific equipment. They're beginning to be just as well versed in water. So that allowed us to understand how much we could, if we could step in and replace all of the scientific and medical equipment, we could have a huge impact, reducing the water and reducing the energy spilled in this campus. Then finally, we took the mirror, we looked at our own HVAC system design, and reduced that by what we know from today's practice at that facility versus if we could come in and design it today versus what we think we'd be able to do in 10 years. So what does that look like in an abstract way? Because we're always needing to diagram things so that the owner can understand what we're doing, where we're going. So we've got the baseline, and today and the future with irrigation, with energy efficiency, with plumbing fixtures, with equipment, with HVAC design. And our water use intensity started out at 29.4 gallons per year per square foot as the baseline. And we've reduced it by 76% to 7.2. Whereupon the architect said to us, well, that's not good enough. So we rethink, we've rethought, we've reduced, and now we have to look at, is it possible to reuse and recycle? And for any of you who are experienced in the healthcare world, you never say to your client, well, let's reuse or recycle water in your hospital. It just doesn't. So, but we're thinking, okay, 10 years from now, what might be possible? So here's today's calculation. So what we've done is we've looked at the water use in the campus, and in that sort of grayish purple color, identified what uses have to be drawn from a potable water supply, and where are we using potable water where if there was a different source, that different source could serve that need just as well. So that's the existing, and then the today is how much we reduced it by, the 70-some%. And then we're looking at the future in the same way. So what we're doing is saying, you're going to have potable water, but let's imagine other sources. So there's a lot of sources for water within a building or campus, and then there's a lot of different demands, and that's the calculus that occurs. In scenario one, what we're saying is that the rainwater, we're going to count the rainwater as potable water. So the potable water sources are going to be rainwater and municipal water, and in scenario two, it's just going to be municipal water. So we're testing to see if we can capture all of that rainwater, we can clean it, we can reuse it, what's going to happen. So in that first one, you see the purple is the municipal, it's less than the roof water, and we're going to use it for consumption, for shower, for some cooking and some process. And the non-potable water is going to come from groundwater from the buildings and the site storm water. And we're going to use that for landscape shower and the remainder of the cooking and the process, those parts that don't demand potable water. And then scenario two, same idea, but we're just using city water. And the way we're still, instead here, we're recycling the roof water and we're recycling the gray water. All of which gets us to net zero water campus. So in conclusion, I want you to think about what are the academics bringing to us that's of interest. And this one comes from MIT.
Today, 39% of all the fresh water taken from rivers, lakes, and reservoirs in the United States is earmarked for the cooling needs of power plants that use fossil fuels for nuclear power. The problem? A large portion of that water ends up floating away in clouds of vapor. In other words, hundreds of billions of gallons of clean, otherwise usable water are lost each year. But now, a new system devised by a team of MIT engineers could provide an efficient, low-cost way to capture a substantial amount of that lost water, ultimately making power plants less wasteful and more self-sustaining, and the water collected could become a source.
So what this MIT strategy ultimately wants to do is reuse all of that water that it's captured for drinking water. So whether it's this gentleman on the far left who's all on his own, whether it's the man who can't describe his product in less than 5 minutes but has an amazing product, or whether it's the one who's gone through 3 layers of funding, pay attention to these people because there's a lot of good ideas out there that are going to find their way into your design world. Rethink, reduce, recycle, and reuse your water in your healthcare facilities.